Hello, this video will show how to use LiDAR Explorer to find and download DEMs for your area of interest. The first thing we're going to do once we get to LiDAR Explorer is click on the DEM tab, and then we want to define our area of interest. The area that I want to find and download digital elevation models for is a location in Butte, Montana, known as the Berkeley Pit, which is a former open copper mine that has since filled with water that is heavily contaminated, and so now it is one of the country's biggest Superfund sites. So to find this particular location, I'm going to go up here to locate a place and start typing in a Berkeley Pit. And we can see that we have a hit here, so I'm going to click on that. And once I get to the location, I'm going to change my base map just so that I can see the pit a little bit more clearly. So click base map, then select the aerial, and I'm going to zoom out until I see the full extent of the Berkeley Pit. So this is the area that I am interested in finding elevation data for, and not only for the pit itself, but its surrounding geography as well. So I'm going to draw my area of interest, essentially the area that I want to find DEM coverage for, by using this tool here. I click on it, and then I hold my control key down and drag a box over the area that I want DEM coverage for. So I select that, and you can see your area of interest gets highlighted in red, and then over here in your results area, not only do you get your DEM results, but you also get your LiDAR results as well. But again, we're interested in DEMs for this particular example. From here, you're going to see what is available in this particular archive. We can see that we have 2 digital elevation models at the 10-meter level and 2 at the 30-meter level. Obviously, 10-meter resolution is better than 30-meter resolution, so that's what we're going to select. So if I click that, you can then see the 2 that cover your study area. And if I zoom out a bit on this, if you hover over each one, you can see the actual spatial extent for that particular DEM. And so you can see that most of it's in this top one, but there's just a little bit of it that's also in this bottom one. So we're going to download both of these. So I would just simply click on this little download button here, and these will begin to download, and you can see those right here. Once they are finished downloading, you can then add them to ArcMap. So we are going to add them to an empty ArcMap project by opening up ArcGIS Pro. Starting a new project with using a map template. I'm just going to call this Butte, since this is Butte, Montana. Click OK, and an empty project with a map will show up here for us to begin adding data to it. So here we have that. So now that we have a map to add data to, we go to our Map tab, select Add Data, and then add data from the location where we saved our digital elevation models. So I saved mine in a folder called the Berkeley Pit, so I'm going to add both of those to the map. And once they get added to the map, it's going to zoom you into that particular area, and it's going to overlay it on the base map that you currently have in your project, which I'm going to shut off just for the sake of loading purposes. You can see that there's a seam between the two, so what we want to do is mosaic these together by using the Mosaic to New Raster tool. To find the Mosaic to New Raster tool, we come up here to Analysis, select Tools, and then from here we can do a search for the tool. And we want Mosaic to New Raster, so we select that. We put our input rasters, which are the 2 that we want to stitch together. We select the location where we want to save our DEM, our Mosaic DEM. And then we name the DEM with the file extension that we want. we select the spatial reference. I make it match the input data, so I'm going to select one of those. The pixel type that we want for this would be a 32-bit float. This is one band data since it's a DEM. And then the mosaic operator, I am going to select blend. I then click run, and it will run the tool. And what will happen then, and I'm going to not make you suffer through it creating the new raster, but once the new raster is created, it will be in the folder that you specified, and now you can see that you don't have that seam between the two, and you can see that it took the lowest elevation value of the two and the highest elevation of the value of the two and stretched it out, the mosaic out between those values. So now that we're done mosaicing our images, there's no need to keep those original images in our project. So now we can just work with this. If I wanted to, I could, before creating any more terrain related data sets, I could clip this to just have whatever area that I wanted on the map. So like I might just maybe want this region here. I can zoom into that, go to my imagery tab, go to process, making sure that my image is highlighted, go to imagery, then go to process, and then it will clip the DEM just to that area that was in your spatial extent. So it's a really quick, easy way to clip your imagery. Now that you have the imagery at the spatial extent you want, you can begin to create elevation-derived data sets. And you can do that in a number of different ways in ArcGIS Pro, but I'm going to show you using the toolbox method. And this time, instead of searching for the tool, I'm actually going to drill down for it again, just so you see something that's a little bit different. So the surface tools are located in both the 3D Analyst and Spatial Analyst toolbox. In the Spatial Analyst toolbox, they're under the surface toolbox. And the first one that I'm going to run, which happens to also be my favorite, is the hillshade. And I'm going to select the clipped raster, and then I'm going to rename this hillshade pit. And I'm going to keep the other items. And this is just giving me a warning. And I'm going to hit run. And you can see that the hillshade has completed. I can then click the back button here and then go to my slope tool and again input the raster that we want the slope data for, and then hit run. And once it finishes running, it will add that data set to the map. I'm going to just turn that one off, go back, select aspect, and if you remember, aspect is the direction of the slope. And I'm going to select again the pit. I'm going to rename it aspect pit, and then again hit run. When this particular data set adds to the map, it's going to show you the direction of the slope like in this fashion. Finally, I'm going to create some contours. I'm going to go to the contour tool, and to create the contours, I'm going to take a quick look at my elevation range that I have. And I'm thinking that I might try with this a 50 meter contour interval. And so with that, I'm going to actually name this 50M in the output name, put my interval in there, and then click run. While the hillshade, slope, and aspect were raster data sets, essentially images, your contour data will be vector data or a shape file or a feature class. So we can see what that particular interval gave us. If we decide that that's too close together, we can just go and run it for a different interval. But for the sake of this demonstration, I'm just going to leave it at that because I just wanted you to know how to use the contour tool to create contours. Now, let's go back to our hillshade and our digital elevation model. I'm going to move my digital elevation model above my hillshade, and I'm going to come up to my appearance tab, and I'm going to change the symbology of my DEM to one of the elevation color schemes that is available. I click on this drop down arrow, and notice that you don't see you can't necessarily know which ones are elevation, but if you click show names, it makes it really simple and easy to find color schemes that are appropriate for your particular phenomena. So I'm selecting, I believe I will go with number 7, and I'm then going to come up here and set a transparency so that we can see below to the underlying hillshade such as that, which looks kind of cool. If I wanted to, I could then play with some stretches to make this look a little bit more vivid and give it a little bit more contrast. I can also use DRA so that the as you zoom in and out, it redraws itself and dynamically renders your hillshade and DEM. You can also play with resampling to get a clearer or more pronounced elevation look to your digital elevation model. So this video showed you how to find DEMs, how to add them to ArcMap, ArcGIS Pro, how to mosaic your digital elevation models, and then how to create terrain-related data sets from that digital elevation model.